Alright, so let's take a look at angles of elevation and depression. So in order to do problems with angles of elevation and depression, you have to know your trigonometric ratio. So let's review a little bit. So if you remember the acronym SOHCAHTOA, so what is our ratio for sine? Well, it would be opposite over hypotenuse. Cosine, can you remember? Adjacent over hypotenuse. And tangent, what would that be? It would be opposite over adjacent. So we're going to be using these same trigonometric ratios to complete problems involving angles of elevation and depression. So what exactly is an angle of elevation? Well, when looking up at an object, the angle of elevation is formed by the observer's line of sight and a horizontal line. So if you look at this image here below, this is our horizontal line here. Alright, and this little guy here is looking up, and so this would be our angle of elevation. So the horizontal line and looking up at an object. So that is the angle of elevation. So let's try an example. Example 1, it says Casey sights the top of an 80-foot tall lighthouse at an angle of elevation of 58 degrees. So we have our image here. So this lighthouse is 84 feet tall. And the angle of elevation is 58 degrees. If Casey is 6 feet tall, how far is he standing from the base of the lighthouse? So let's label Casey here. He's 6 feet tall. And we want to know how far he's standing from the base of the lighthouse. So basically we want to know the length from here to here, right? So that would be the same length right here, the bottom of this angle. Not angle, the bottom of this triangle here, because that would be the same length. And so we could find the length, if we found the length of this side of the triangle, we would also find the length from the base of the lighthouse to where he's standing, because it would be the same. Alright, so do we have enough information? Well, the lighthouse is 84 feet tall, Casey is 6 feet tall, and so we could find the length of this side here, the side adjacent to the right angle. Let me make it a different color here so you can see. So this side here. So if we subtract 84 from 6, we get 78. So the length of that side of the triangle is 78 degrees. So now we could use one of our trig functions to find the value of x. Alright. So in reference to this angle, that 58 degree angle, we have the opposite side and we have the adjacent side to that angle. So now what trig function uses opposite and adjacent? If you can remember, that is tangent. So let's set up a trig ratio. The tangent of 58 degrees is equal to opposite, so that would be that 78 foot height, over adjacent. We don't know what that adjacent side is, so we have to solve for x. So now hopefully we remember how to solve these trig problems. I want to solve for x, so I need to multiply both sides by x. Alright, I'm left with x times the tangent of 58 equals 78, because my x's cancel out. Since this is x times the tangent of 58, I'm dividing by the tangent of 58 on both sides. Cancels out. And x is equal to, so 78 divided by the tangent of 58. If you type that in your calculator, type in 78 divided by tan 58 and click enter, and you're going to get x is equal to 48.7 feet. So that is our length from the base of the lighthouse to where Casey is standing. So let's look at these two examples here. It says the angle of elevation from a kicker's foot on a football field to the top of the goal post bars is 17 degrees. If he is standing 131 feet from the base of the goal post, how tall is the goal post? So it helps to start out by drawing a triangle. Save some time, I have it already up here. But if we have our kicker, this is my kicker, all right. This is my goal post right here. And the kicker to the base of the goal post would be that 131 foot length. Angle of elevation from the kicker to the top of the goal post would be going up. So that would be 17 degrees right here. And we want to know how high the goal post would be, which is this piece here, this length. All right, no, that doesn't look like a goal post, but it is. So now we have everything we need. And so we have that 17-degree angle. That x would be the opposite. 131 would be adjacent. So once again, we're using tangent. So tangent of 17 degrees is equal to opposite, which is x, over adjacent to that 17-degree angle, which is 131. Solving by multiplying both sides by 131. Cancels out here. I'm left with 131 times tangent of 17 is equal to x. Most calculators, you can just put it in as 131 tangent 17, enter. But some you may have to do 131 times tangent 17, enter. But you should get x is equal to 40.1 feet. So that is how high the goal would be. All right. Let's take a look at the next example here. It says a dog is standing 5 feet from the base of a tree. Let me pull up my image here. All right. So this is my dog. There we go. He has 4 legs. So he's standing 5 feet from the base of a tree. So we could say that this is my tree here. All right. And looking up at a cat, so his angle of elevation will be here. That has climbed 16 feet up the tree. What is the angle of elevation from the point the dog is standing on the ground to the cat? And so our cat would be up here somewhere. Yeah, I know it looks just like the dog, but that's the cat that he's looking at. And so we're looking for the angle of elevation. So remember, if you're looking for an angle, you're using the inverse trig function. So we're going to set it up. So we have opposite, once again, over adjacent, because we're looking at this angle here. So that will again be tangent. So tangent, or inverse tan, because we have to find the angle, is equal to opposite, which is 16, over adjacent, which is 5. So the way you would put that in your calculator, so I'm going to actually rewrite this. Well, I actually should have put an x here before I put the tan. So tangent of x, and then once we do our inverse, this is how it will look in your calculator. There we go. All right, and so if you still need some help with the inverse trig, go back and review the video, right triangle trigonometry. All right. So when you put in your calculator, it would be second or shift. Some calculators have shift, tangent, and you should see tan -1. And in mine, I have to put parentheses around my fraction. 16 divided by 5 and hit enter. But you should get x is equal to 72.6 degrees. So the angle of elevation is 72.6. So I would like for you to try this problem here. Go ahead and pause the video, read over the problem, and try to work it out on your own in your notes. So go ahead and pause the video. All right, so the answer was 12.5 feet, and we actually used sine in this problem. I know for our other three examples we used tangent, but here we had the hypotenuse, or we were looking for the hypotenuse right here because you're looking for the length of the slide, and the slide is diagonal, right? So you would be looking for that hypotenuse. So opposite over hypotenuse would be sine. So hopefully you got the problem correct. If not, pause the video and analyze this problem a little bit more. So let's take a look at angle of depression, and that is when looking down at an object. The angle of depression is formed by the observer's line of sight and a horizontal line. So similar to angle of elevation, you still have that horizontal line, but instead of looking up, you're looking down for the angle of depression. We want to make note of the fact that the angle of depression is congruent to the angle of elevation because they are alternate interior angles. So if we're looking at this image here, so we have this horizontal line right here, right? And if the lifeguard here is looking down, right, that would be the angle of depression. However, this angle here would also be congruent because these would be alternate interior angles, because we could look at this line here as a transversal. All right, so let's try an example here. It says a lifeguard is sitting on a platform looking down at a swimmer in the water. If the lifeguard's line of sight is 8 feet above the ground and the angle of depression to the swimmer is 18 feet, how far away is the swimmer from the lifeguard? So he's 18 feet above the ground, or 8 feet above the ground, and so we could say that the length right here would be 8. And then it says the angle of depression is 18. All right, so which would make this also 18 degrees. How far away is the swimmer from the lifeguard? So we want to know this length here. So we can actually find this length or this length. It does not matter, because if I actually drew just a perpendicular line here, I could use this triangle here. But either way, you're going to get the same answer, right? So if I have this 18-degree angle, I want to find this piece here. So that would be adjacent. So even if I use this 18-degree right here, it would still be adjacent. So I have adjacent and I have the opposite side. So once again, I am using tangent. So tangent of 18 degrees is equal to, so if I'm using this 18 degrees, this would also be 8 as well. Opposite over adjacent. Or if I'm using this 18 degrees right here, it will still be that this 8 would be opposite over adjacent. So same thing, all right? It's just if I'm using this angle up here, I'm drawing an extra line. So solving this trig function the same way. At this point, you probably know that when I multiply both sides by x, I'm going to end up just dividing, right? So skipping a step here, I'm going to end up with 8 divided by tangent of 18. Because when I multiply both sides by x, I end up dividing by tangent of 18. And putting that in your calculator, 8 divided by tangent of 18, you are going to get 24.6 feet. Alright, so that is how far the swimmer is from a lifeguard. So this length here would be 24.6 feet. So let's take a look at this example here. It says a pilot in a helicopter spots a landing pad below. So below tells us that that is going to be an angle of depression. So when you're doing your own work, it's not going to say this is an angle of depression or angle of elevation problem. You have to look at those keywords. So below, looking down would be depression. If it's looking up or above, that will of course be elevation. So The pilot is spots a landing pad below, letting us know that that is depression. If the angle of depression, well, this problem actually tells us the angle of depression, but sometimes it will not. All right. If the angle of depression is 73 degrees and the horizontal distance to the pad is 1,200 feet, what is the altitude of the helicopter? Remember, altitude means height. And I'm going to actually draw my picture because you may ask, how did she know to draw that triangle in the previous problems? And so just looking at that information, let's draw it. So we can draw our helicopter. I know this does not look like an airplane, but that's what it is. Okay, he's looking at the landing pad below. So this is my landing pad here. All right. The angle of depression is 73 degrees. So here, that is going to be 73 degrees because this would be my horizontal line. And the horizontal distance to the pad is 1,200 feet. So horizontal, of course, would be from left to right. So that would be 1,200 feet, right? What is the altitude of the helicopter? Altitude is the height. So we could find this length. I could draw a perpendicular line here, or I could draw a perpendicular line here. All right. And so if this is 73 degrees, again, this would be 73 degrees. All right. And so once again, we have opposite over adjacent, tangent. So tangent of 73 degrees is equal to opposite, which is the x, over adjacent, 1,200. All right, that is my ratio there. Solving it, multiplying both sides by 1,200. 1,200 times tangent of 73. If you put that in your calculator, you should get x is equal to 39.25. Not point. It's just 3,000. No point. 3,925 feet. So that is the altitude of the helicopter. Alright, so we finally reached the last problem. I know this video was a bit long, but we had a lot of information that we needed to cover. So go ahead and pause the video and try this last problem on your own. So you should have gotten 141.1 feet. If not, go ahead and pause and look over and analyze this problem, but hopefully you got it correct. So we reached the end of our lesson. I want to thank you for learning with me. Related videos are right triangle trigonometry, and that is where you can review on those trig functions if you need a refresher on that. Also the Pythagorean theorem and special right triangles. If you haven't already, please like, comment, share, and subscribe. And once again, I would like to thank you for learning with me.